Okay, moving on to example 2, we got 5 to the x equals 40, the same basic structure the last problem was, right? We have some number 2, power equals a number. But the issue here is if I try going 5 times 5 is 25 times 5 is 125, it skips over 40, right? So we don't have this ability to get down to a power structure, all right? So what I'm going to do in a situation like this, if I have an exponential equation, so my variable's up in the power level, I want to get my exponent, or my letter down to the not power level, and logarithms allow us to do that. So you pick your favorite logarithm, either ln or log, I don't care which one it is, but one of those two. Now the only time I'm ever going to say use this one specifically is this. If this says e to the x, use ln. If it says 10 to the x, use log. Otherwise, use whichever one you like. I like ln better. So I'm going to log both sides. So we have a rule, one of our log rules says, if x equals y, then log of x base something is equal to log of y base the same thing. That's one of the rules. I think it's number 5 on the list of rules I gave you with the laws of logarithms. Okay? That's the rule we're going to use. We have an equation, we're going to log both sides of the equation. So ln of 5 to the x power is equal to ln of 40. Or again, I can go with log, take your pick, doesn't matter. Now, the reason I want to go logs is because we have another law of exponents which says, our law of logarithms saying that if we have a power in the argument, that power is allowed to move out in front of the logarithm, right? So that gets me x out in front times ln 5 is equal to ln 40. Then I go on to solve this, I end up getting x equals ln 40 over ln 5. And finally, for the best, most beautiful answer I could possibly make for this, I can change it into a single logarithm. X equals log of 40 base 5. Just using the change of base formula in reverse, right? Got the same log, same type of log on top and bottom. So it's log of this number base that number is what that means. That's the exact answer. Let's see. Anytime they ask for the exact answer, they're looking for an answer looking like that. Log of something base something. That's what we're looking for. If they ask for an approximate answer, or they don't specify, sometimes they do that. Find the answer. This says solve. It doesn't specify find the exact answer, right? So they say approximate answer. Once we get to this point here, my calculator has an approximation for ln 5, which it tells me is 1.6094, which is being multiplied by x, right? We prefer to have x's after the number, equals, and if I do ln 40, my calculator knows that one too, ln 40, and it's 3.6889 if I round 4, so 3.6889. I do want 4 decimal places in your approximations in your work. So if we divide both sides by 1.6094, we're going to get 3.6889 divided by 1.6094. That comes out to 2.2921. I'm going to go 2.29. 4 decimal places in your work guarantees us a pretty decent 2 decimal place approximation per answer. What this is telling me, that's approximate. If you're going to go for approximate, I immediately, once I get the x out of the power level, that's when I go ahead and go approximate right then. Immediately. So once I've made the decision I'm going approximate, those logs change to these decimals and I'm ready to go. All right. If I were to type in 5 to this power, it should equal 40. Actually be a little bit less than 40. I know it's a little bit less than 40 because I rounded down. Alright? So if I do 5 caret 2.29 comes out to 39.8695. Not exactly 40, but pretty close. If I'd gone 5 caret 2.29209643, that's going to be a lot closer to 40. Still not exactly because these are both approximated, right? But 40.004, still really, really close. All right, so just know that that's what you're finding is the power in this case because that says 5 to the x. If I said 5 to the x plus 17, I have to add 17 before I do 5 to that power to get it, whatever. So, but keep that in mind that we have the ability to get the power out of the power level using logarithms by using this rule that says the power can go out in front. Once it's out in front, now it's just a basic algebra equation, just a little bit uglier than the one you had to do in algebra class.